All right. Well, my recording app keeps crashing in the middle of my recording, so we are doing 4.1, take 2. Okay, they changed all kinds of things for me. Okay, 4.1, solving linear inequalities. Solving linear inequalities. Okay, so we are mainly going to focus on how to represent the solutions of an inequality. So what we're going to take a look at are two different ways: interval notation, which I talked about during when we covered domain and range, and then a new way to represent that same solution set using set builder notation. Okay. All right, so let's take a look at this inequality. X is less than or equal to 5. So we're going to be looking at how this solution can be represented using a graph. And then we will look at interval notation. And then we will look at set builder notation. Okay, so for the graph, that's going to be on a number line, not like an XY plane. Okay, so here, let's put 5 here, 6, 7, 8, 4, 3, 2, 1. Okay, so x is less than or equal to 5. So here I will have a bracket instead of a parentheses. And I will shade this side. Okay, as far as the bracket and the parentheses go, bracket is like closed circle. If you graph this before using open circle and closed circle. So the bracket is equivalent to the closed circle. The bracket means 5 is included in our solution set. Okay, so if you'll use brackets, this one or this one, depending on the direction you're shading. So you'll use that when you have the less than equal, greater than equal, and you'll use parentheses, that one or that one, if you have the strict inequality, that one or that one. Okay. Interval notation. So we see here that on the left side, it's unbounded, and on the right side, it is bounded by 5 in a bracket. So unbounded, that's going to be negative infinity on the left, bounded on the right by 5 and a bracket. Okay, so set builder notation, we're going to use this brace. Okay, and we're going to say all real numbers x, and that's all we have to put to say all of that. All real numbers x is represented by just putting that x there. All real numbers x, this line means such that, so all real numbers x such that x is less than or equal to 5. Okay, so this is set builder notation. So this is the new notation. Okay, so again, putting this x here says all real numbers x. Okay, this line here means such that. And here x is less than or equal to 5. So all real numbers x such that x is less than or equal to 5. So when you do set builder notation, you have these curly braces, and you use whatever variable you're talking about up here. In this case, it's x. It could be y, right? And you do your line for such that. And then this is basically the inequality that you have, that you're representing. So you just kind of copy it and put it there. All right, let's take a look at another example. So let's take a look at x is less than 5, strict inequality. And we'll look at all three of these. We'll look at the graph, interval notation, and set builder notation. Okay, so starting with the graph, and then we'll do interval notation. and then set builder notation. Okay, so here we go. There's 5, 6, 7, 8, 9, 4, 3, 2, 1, 0. Strictly less than 5. So no bracket, parenthesis this time. Okay. But I will still shade this side of the number line. So interval notation. Again, unbounded on the left, bounded on the right by 5. So unbounded on the left means negative infinity, bounded on the left by 5, parentheses. Set builder notation. All real numbers x such that, and all I do is copy down this inequality. X is less than 5. Okay. Let's take a look at another one. So you see the difference between these two here. This is x is less than or equal to 5. So x can be a number that's less than 5 or equal to 5. So 5 is part of the solution set. So this is how we show that 5 is included in our solution. If it's a strict inequality, x is strictly less than 5. It cannot equal 5. Then we represent that with a parenthesis. Okay? All right, let's take a look at this third example. Suppose that I have this, x is greater than or equal to 5. Okay, so again, we will look at what that looks graphically, and then interval notation. And set builder notation. Okay, so graphically, so here is 5. Okay, so greater than or equal to 5. So that's going to be a bracket. But now we're going the other way because we want all the numbers that are greater than or equal to 5. Okay, so interval notation. So here we are bounded on the left by 5, unbounded on the right. So bounded on the left with a bracket 5 and unbounded on the right. So that's infinity. The infinities always have parentheses. You don't have to put the plus. That's just something I do. I think that's old school. Okay. Set builder notation. So curly brace, all real numbers x, such that, copy down your inequality, x greater than or equal to 5. Okay. And let's take a look at the strict inequality version of that, x greater than 5, strictly greater than 5. So here we'll look at the graph, interval notation, and set builder notation. Okay, so the graph, let's take a look at this. Here's 5, 6, 7, 8, 4, 3, 2. Greater than 5, strictly greater than 5. So that's going to be a parenthesis. And I'm still going to shade this side. So again, the difference between these two here, greater than equal, we get the bracket. Strictly greater than, we get the parenthesis. Okay? And then interval notation, we're bounded on the left by parentheses 5, unbounded on the right. So parentheses 5 on the left, unbounded on the right. So that's positive infinity. Set builder notation, all real numbers x, such that x is greater than 5. Okay. So that's how we represent the solution sets to inequalities. A couple of notes here. So note one. If solution is all real numbers, all real numbers. So if that's the case, then when you take a look at your graph, then that means you are shading the entire number line. Okay, if we talk about interval notation, well, you're unbounded on the left and you're unbounded on the right. So unbounded means negative infinity and positive infinity. Okay, and when we do set builder notation, we actually just use the symbol for real numbers, and the symbol for real numbers is a boldface R when you're typing things out. But when you're writing things out, how are you going to do a boldface R, right? So we actually use this for our boldface R to mean all real numbers. Okay. Note number 2. So that's if you have all real numbers for your solution. You might have the case that you have no solution. If you have the no solution case, then your graph, you won't have anything. Okay, and for your interval notation, you would actually say no solution. That's what you would write down. And then for the set builder notation, we actually have a symbol. And that symbol is this, which means empty set. Okay, so that's all you would have to write. Again, you don't write empty set, you just use that symbol, but I'm going to write down what it means. It means empty set. It means your set of solutions is empty. There's nothing there. Okay, so let's take a look at an actual example of solving. So solving. Let's go ahead and solve this multi-step. -9 times h minus 3 plus 2h less than or equal to 8 times 4 minus h. Okay, so the solving process is pretty much the same as solving equations. There's one little bit at the end where it might differ depending if you're multiplying or dividing by a negative number. If you end up doing that, then you have to switch the inequality. So if you're multiplying or dividing both sides by negative, you have to switch the inequality. All right, I'm going to go ahead and do my distributive property, okay, on both sides. So over here, I'm going to distribute -9. And on the right-hand side, I'm going to distribute the 8. Okay. And over here, I'm going to go ahead and simplify this a little bit more. I'm going to go ahead and combine my like terms on this side. I only have 3 terms here, so I can only combine like terms within these 3 terms. Okay, so that would be -9 and +2. Okay, -9h and +2h. Okay, and then on this side, on the right-hand side, I can only combine like terms within these 2 terms, and we do not have any like terms, so I will just copy that down. Okay, so all I've done so far is distributive property and combine like terms on each side. Okay, so now I can begin my solving. So I'm going to go ahead and do this to remind you that what you do to one side, you have to do to the other. Okay, we have variables on both sides. We have a negative 7h and a negative 8h. So you have two choices. You can either cancel this one by adding 7h on both sides, or you can cancel this negative 8h by adding 8h on both sides. It doesn't matter which one. You'll get the same answer. Okay, so this is what I'm going to do. I'm going to choose this one. I'm going to go ahead and add 8h on both sides. Okay, and when I do that, they cancel over here. And so I'm left with not 7, I'm left with 1h plus 27 on the left side. And on the right side, I'm left with 32. Okay, finishing solving here, I'm going to subtract 27 from both sides. Okay, and when I do that, I get h is less than or equal to 5. Okay. All right, so now I'm going to graph this, and I will do interval notation. I thought my screen recorder was about to crash again. Okay, interval notation. Usually a notification pops up right there telling me it's crashing. Okay, set builder notation. And I'm almost done, so. Okay, so when we graph this, here's 5, 6, 7, 8, 4, 3, 2. Less than or equal to 5, so that's going to give me bracket, and I'm going to shade this side. And interval notation unbounded on the left, so that's negative infinity. Bounded on the right by 5, bracket. Set builder notation, not x, not all real numbers x, all real numbers h, such that h is less than or equal to 5. Okay, so that is pretty much it. Again, if you're solving inequalities, and let's say you end up with something like this, negative 5x less than or equal to 25. Let's not make 25 is too easy. Let's do 35. Okay, so in this case, to solve for x, we would need to divide by negative 5. So this is what I'm talking about. If you end up dividing both sides by negative 5, if you do end up doing this, you have to change this. So this is gone, and you have to switch it. So x is greater than or equal to negative 7. Okay, so if you're multiplying or dividing both sides by negative, you have to switch the inequality. Okay. All right, so we made it through without my recorder crashing. Okay, so if you have any questions, make sure you message me. I'll see you next time.